A bug in the programming world is not some kind of insect. Rather, it's an error or flaw in your code that causes the program to fail or behave unexpectedly. There are two types of bugs. Compile time errors are bugs that show up during compile time and usually causes the program to not compile at all. This results from a typo or syntax error in your code. Runtime errors are the second type, and these won't show up during compilation, but only show up once the program has started running. Compilers normally won't catch this type of bug, so it'll be up to you to test for and fix them. Finding and fixing compile time errors is usually a straightforward process. The compiler will give you an error. In Arduino, this shows up as bright orange text in the message pane. If you see orange text with the word error in it, the first thing you should do is always read it very carefully. More often than not, it'll tell you where the error is. Let's start by creating a common syntax error, forgetting the semicolon. In setup, write serial.begin 9600, but make sure to leave off the semicolon. Try to upload the program, and the space between the text entry and message panes will turn orange, telling you that something went wrong. Expand the message error if you need and carefully read the text in orange. The first line tells us where the error occurs, in which file, our sketchname.ini, and in which function, setup in this case. The next line tells us on which line the error occurred. Here it's in our sketch on line 3. If we look at line 3, which was nicely highlighted for us, we just see a curly brace. Well, there's nothing wrong with that, so why the error? Well, we need to read a bit more. Back in the messages, we see error, expected semicolon before curly brace token. That means the compiler is missing a semicolon. So we start looking near line 3 for a statement that's missing a semicolon, and we can find it just above. Add the missing semicolon and try compiling again. Everything compiles just fine, so we're done. Finding and fixing bugs like this is a process called debugging. Another common compile time error is forgetting an open or close parenthesis or curly brace. If I create a for loop and accidentally remove the close parenthesis, I'll get the following error: expected curly brace at end of input. If you look at the code, you'll see the last curly brace highlighted, even though this isn't where our error is. That's because the compiler saw one closed curly brace, but was expecting two, so it shows us that it's expecting one more. If you see this, take a look at your loops and if statements for missing curly braces. There are lots of mistakes that can be made when writing code, so the best thing you can do is click the verify or upload button and check your code often. The verify button just compiles your code without sending it to the Arduino. It's useful for seeing if you typed everything correctly. Replace the string in the print statement with a variable like A. Try compiling this and you'll get another error. If you can't figure out what this error message means, you can always ask your local search engine. Highlight the error message, but leave out any file, line, or variable names. Other people are not likely using your same names. Press the copy command shortcut on your keyboard. Open a browser, go to google.com, type Arduino, so Google knows what kind of platform we're working on, and paste your error message. Search, and you should see people having similar problems. Start clicking and reading articles with titles that look like your issue. Here, we find that we're missing a variable declaration. Aha! We didn't declare or define A before we tried using it. Back in our code, declare A as an int and give it a value, like 100. Now our program should compile and run just fine. Runtime errors can be a bit trickier to track down since we won't get compiler error messages. Let's try to divide A in our print line by our counter, I. Do you see a problem here? We're trying to divide a number by 0 in the first iteration of the for loop. In mathematics, this generally can't be done, or sometimes we say that it approaches infinity. Either way, it doesn't work too well in computer programs. Surprisingly, this will compile and run, but it gives us garbage for the first result. Since I just told you where the error is, you probably have some ideas on how to fix it. However, let's say that you get a runtime error like this and you have no idea what's causing it. You can stare at your code and step through it and draw flowcharts, but that gets tedious pretty quickly. In this case, the serial.print command is your friend. We can use it to examine the contents of variables before they're used. Add the following just before our print line: serial.print a, serial.print space / space, serial.print I, serial.print space = space. Run this and open a serial monitor. You should see your math operation a divided by I equals some result on each line. This should give you an idea of what you're trying to perform. You can also deselect the auto scroll option in the serial monitor to stop the wall of text from flying by in order to read your output more easily. Take a look at your first line. There, we're trying to divide by 0, and that's not allowed. Change int I equals 0 to int I equals 1 to start dividing by 1 instead of 0. Run it and watch the output. Much better, no more divide by 0. Delete the a definition and print lines. In the for loop, add if I equals 10, open curly brace, / LED turn on, close curly brace. In this trivial example, we want to do nothing while I is counting, and then turn on an LED when I reaches the end. Let's say we run this and the LED never turns on. Is it an electrical issue? Did we hook up the LED right? Or did we do something wrong in the code? Well, we can test the code by injecting print lines. Above the if statement, add serial.println I, so we can watch the counter. Then, in the if statement, add serial.println turn LED on. This will tell us if we ever get inside the if statement. Run it and open the serial monitor. We see I counting up to 9, but never the turn LED on statement. That tells us the if statement is never true. Looking at the values for I, we see that I is never 10, so the if statement always evaluates to false. We can fix this by increasing the maximum for I or setting the if statement to I equals 9. Run it, and we see that it works as expected now. When I reaches 9, the if statement executes. These are just some of the errors you might come across, but knowing how to track down the errors is the important part. You'll need to think like a detective. Look for clues and narrow down portions of your code where you think something has gone awry. There's no shame in using Google for compile time errors, and serial.print is your best friend when it comes to runtime errors.